Soil and ecological site identification is probably one of the most important steps in any inventory, assessment, or monitoring project, no matter what type of land you're working on. It's an important process because it allows us to establish what the ecological potential of a particular piece of land is, what's possible for that piece of land, what's not possible, and what's likely to require significant inputs in order to generate particular changes that we're looking for on a landscape. Obviously, we're going to need other pieces of information in addition to the ecological site identification to make those determinations. Things like an ecological site description, state and transition models, other information that we have about the dynamics of that landscape. But the first step is always to determine where we are on that landscape and what the soils are. So the first thing we do when we get to a site is we start by looking around and figuring out where we are in this landscape. And as I look around here, I know we're in the Jornada Basin because I looked at a highway map before I got out here. And I also know that we are in the lower part of the basin. We've got mountains on both sides. I've got a good idea that those have probably been contributing some sediments. And in this particular case, I happened to talk with an expert at the university, Dr. Curtis Monger, who informed me that this is also an area that has received a lot of aeolian deposition. In other words, there have been an awful lot of windblown sediments that have ended up on this basin. So I was guessing, based on that and the soil map, although the soils map is not of particularly good quality, but I was guessing that I would probably be on some fairly coarse sandy soils in this particular part of the basin. And in fact, as I look around, it does look like the soils are fairly coarse and sandy. The next thing that I need to do now is define the area that I'm actually going to be working in. Define the area that I'm going to set up as my monitoring point or as my assessment. And again, looking around, I'm looking for a relatively uniform area that I'm going to use for that. And I'm going to go out maybe 50 yards or so, and I'm actually going to walk through this area and look for any particular parts of it that seem to be somewhat unusual in terms of the microtopography, in other words, the slope of that, or in terms of some of the soil surface characteristics. So I'm going to walk out here a little bit to this bare area behind me and take a look at that. So I've walked out here, I've only walked about 10 yards, and suddenly I'm in a completely different area of vegetation cover. Where I was standing before, a lot of grass, probably 50–60% cover. Here I've got maybe 20% cover. And then if I look right behind me, I've got an area that's dominated by snakeweed. Now, that's a really different set of vegetation in each of these three areas, and they're only about 10–15 yards apart. Am I in a different ecological site? Well, I won't know until I dig the hole. But looking at the soil surface, it all looks pretty sandy. This looks like we're a little bit lower in here, maybe a little bit more clay in the soil, a little bit more crusted. But basically, the soil surface looks pretty similar. So the next thing that I'm going to have to do is to dig a hole in each of these areas and determine which ecological site I'm actually on. So now we've walked around the site. This particular area that we started off in, it turns out, looks fairly representative of much of the site, and it's where I'm going to go ahead and dig my first hole. And when I dig my hole, I'm going to be using this hole a lot of times, not just to determine what the soil and ecological site is, but also to perhaps look at some indicators later on, like compaction, soil organic matter, and so forth. So I'm going to dig it in an area that's not only representative of the soils, but also representative of the vegetation. And I think this area right here, where I've got kind of a bare patch, but also some vegetation surrounding it, is actually pretty typical of this particular site. So I'm going to start digging my hole right here. I want to make it so that the face of the hole, the face of the pit, is facing the sun so that I can see it pretty well. And you don't have to dig a very big hole. In fact, a lot of folks will actually use an auger. I find that an auger is usually unnecessary, but it can make it easier, particularly if you have to dig a fairly deep hole. Now, I do happen to know for this area that the most critical thing are two. Number one is what's the soil texture, which we're going to do in a few minutes here. And the second is what is the depth of this soil. And in southern New Mexico, where we are right now, the key factor in determining whether we are in a sandy or a shallow sandy ecological site is whether the depth to what we call the petrocalcic horizon. It's a pretty hard, white, kind of rocky layer. Okay, if it's at least 20 inches deep, that's going to make it a sandy ecological site. And if it's less than 20 inches deep, it will be a shallow sandy ecological site. And I'm not feeling anything. It feels pretty sandy, but I'm not quite down to 20 inches. The other thing, as I'm digging down, again, I'm looking at other aspects of that soil profile. Am I getting any change in texture? Am I starting to pick up more clay? If it starts to get harder to dig, that's often a good sign that we've started to get into some more clay. And in this particular case, it seems to be fairly sandy, straight down through the profile. Let's try that tape measure again. And I've gone down now almost 22 inches, and there's no sign of a calcic horizon, or petrocalcic horizon rather. In other words, I haven't hit any rocks or anything. And so I'm going to call that a sandy ecological site, except I haven't really confirmed the texture. It looks sandy to me, but I still want to pick up some of that soil near the surface, and I'm going to determine the soil texture. And I know a lot of people, if you're not a soil scientist, haven't had a soil science class, you say, oh, I can't do that. You need a soil scientist to do that. You don't. All you got to do, wet up some of the soil in your hand and see if you can make a ball out of it. And in this case, I've got it nice and moist, and I can't even make a ball that won't crack. That's a pretty sandy soil, okay? If I'd been able to make a ball out of it, the next step then is I'd try to make a ribbon out of it. Well, this won't make a ribbon at all. This is almost like a beach sand. Okay, so the next thing I'm going to want to do is just check at least one or two other areas within this, one or two other pits within this site, and make sure that this is fairly uniform throughout the site, that this wasn't just an anomaly that I happened to hit in this one particular location. So when I walked around this area, I noticed that in addition to those relatively sandy and higher areas or sites within this area, there were also some lower areas, maybe about a foot lower in elevation, and it appeared that they were somewhat finer textured. I noticed some physical and biological crush showing up in these slightly lower areas, a little more grass cover, and I thought, well, there's a possibility we maybe have a complex of two different ecological sites in here. So to test that, I went ahead, I dug another hole, grabbed a sample, did the soil texture, and what I found was, in fact, there is a little bit of variability here. This is a little bit finer textured soil, but it's still a loamy sand. Not quite as sandy as that other spot, but sandy enough to put it in the sandy ecological site. The other thing I found was that, again, this pit, I went down at least 20 inches or 50 centimeters, and I did not encounter any sort of restrictive layer. I didn't encounter a petrocalcic horizon, didn't encounter any rocks, and so based on those observations, I'm pretty comfortable saying that this entire area that we are planning to monitor is in the sandy ecological site, and we can treat it as being a relatively homogeneous area in terms of its potential. So I think with that, we're ready to start making measurements.